Is this alive? It sounds like it's alive. Okay, this is Tech Talk session number 3, Network Physical Security Shortcomings at the Endpoint. If you are looking for something different, you're in the wrong room. My name is Denny Moen. I'm a member of the local FCA chapter and a volunteer to be here and be the moderator for this session. I've been here all day in this room. It's working out really well for me. Better room than I got last year when I volunteered to do this, so I'm pretty happy about it. This particular presentation is worth 1 credit, and to get credit for that, you need, please see me at the end before you leave, and so that I get your little thing scanned, which you probably by now know how to do and recognize the need to do that. If you purchased a registration that included getting credit for a CPE and you're not an FCA member, I'm not so sure how you get the certificate, but in the mail, I know for sure you'll get it if you go down to the FCA booth 123 and become a member, then you'll get it in the email. So I'm not going to talk anymore and turn it over to Mr. Bob Bauman, President and CEO of Trusted Systems Incorporated. And please don't go away after this till into the end of the session until you get a scan from me.
Well, welcome. Can you all hear me okay? I guess I've never used one of these before, so I feel like a little duck out of water here. But let me introduce myself first of all. My name is Bob Bauman, and I am a classic example of an entrepreneur that gets creating a market and a product, and then you're into it forever and a day. And so now you're involved in it so that you can't leave it, nor do I want to. I'm just having way too much fun. But my career goes back a little bit, actually starting out in the Bay Area in the Silicon Valley. And what we're going to be talking about today is really the need to merge cybersecurity and physical security together. That it has been tied to the whole IT industry, but physical security has been, I won't say left in the weeds, but it has been underutilized. And what I'd like to do today is to discuss a little bit about the relationship between security and information technology and go back and review a little bit of the history. I think I look like I'm about the oldest guy in the room, so I'm kind of the IT dinosaur here. So I'm going to go back to some of the early days and give you a little bit of perspective on how things evolved, really starting back in the 50s and 60s, and then put that into context in terms of where we are today, why we have the issues and problems we have, and the opportunities that we have. And it's been an interesting experience for me because it was kind of a trip down memory lane for me, and I'm just been a small little fish in what grew into be a very big pond. But I kind of gleaned onto, after I had been in the Bay Area, I'd moved down to Arizona and had a startup and was a VAR for Sun Microsystems when they first came out. And then from that, did some work up at Los Alamos Labs that got me into the physical security. But what it really was physical security of network and computer equipment. And so we're going to be talking quite a bit in depth about the merging of those technologies, if you want to call it security of technology, and how it's been changing a lot. But as it changes a lot, it kind of stays the same. And what happens is things get moving so fast, particularly in the IT world. And I think the cybersecurity realm is, getting sucked up in the wake of of technology moving at the speed of light kind of thing. And the question is, you have to find what is the perspective, what is its place, and what is its role. So let's get started. And from that, I'm going to kind of basically look at evaluating security a little bit. There's a friend of mine that I met in 1991. Is anybody here familiar with what's called the Macumber Cube? Has anyone ever heard of that? Okay, well then I can tell you a little bit about it. But we'll be working on that. But let's get started. Basically, and the product and company that I have is, whoops, let's go back here a little bit. This is the product that we've made. We make what are called Ips Security Containers, so that's my base of reference for this discussion. But I'm looking more contextual in terms of the industry at large. The problem that we have is one that where attention seems to jump from problem to problem, and it seems to be reactionary to the most recent threat and what's been going on. And cybersecurity now takes all the oxygen in the room in terms of what's going on in security, and rightly so. But it shouldn't take all the oxygen. There are certain problems with it that it can't solve because of its very nature, and things that I think can be helped with in the physical security world. But because physical security has been, relegated to kind of a SCIF environment, and with protective distribution and all these other things, there's quite a dichotomy between the two. And the one area that has not been covered that you kind of get morphed into parts of the market, and I'm driven mostly by my customers, which are people like yourselves, other contractors, government agencies, military branches. I started my company, Trusted Systems, just 30 years ago now. And so it's one of those things where I think it's taken me 30 years to be an overnight success kind of thing. So it's been like a fine wine, right? It's taking time to grow on people. But we're now starting to resonate, and I'll get into why. But the real area that has been missing is in physical security. There is no policy, or in fact technology, we're trying to fill that gap, between the wall and the desktop. When you're in a SCIF and you have either you're in an open area and you have a drop box coming out of a PDS, or you're in a CAA or a SCIF, you have a connection that comes into the room. And if you go between secured areas, you have a protective distribution system, a PDS, that does that and allows you connectivity. But all the classified activity goes on within that room. However, it doesn't protect the equipment that's in the room. And we're going to get into that in a little bit more detail. So this lack of protecting of equipment is in part what gave us Edward Snowden. Because he was in a perfectly cleared SCIF area out in Hawaii, and he had been supposedly vetted, and I'm not going to get into the vetting process with Booz Allen and others, but should have been supervised, and yet he got away with the farm. And part of it was because he had unfettered access to the network equipment that was in that SCIF. Now, when you look at information technology and you look at physical security, they're opposing cultures. And I've kind of listed a couple of things here. Can you see all right? I don't know if I'm in the way here or not. But the first thing is the language they speak. IT is in C4I, ISR, all that kind of stuff. And I came up with an acronym for physical security. I call it G3D. And then it's SLS. G3D is guns, gates, guards, and dogs. And SLS is safe, locks, and steel. And so they're in a totally different world. IT world, of course, you can see, you go down the list, it's fast-paced, but physical security by definition is slow and steady, and it's been pretty level and flat. It's mundane. It doesn't advance a lot because it's supposed to be impervious to the technology that it's protecting. So the technology may change, but the SCIF doesn't. And so some of that is by design, but some of it creates problems. So look at it, and I kind of use an analogy, the IT is moving at the speed of light and physical security moves at the speed of a glacier. And I said, look at me, I'm 39 years old and here I am still waiting, right? But the bottom line is that even though you're looking at all the glitz and the beautiful graphics displays you get in the IT world, and then you're dealing with gray, ugly safes and locks, still, there is quite a disparity there. But what we're really trying to do is we're trying to take the intangibility of the IT world, the cloud environment, and have some tangible countermeasures that can be built in with it so that they can work together. In the IT world, of course, now with the internet and with social media and everything else, everybody, including your kids and my grandkids, want everybody to see everything all the time, right? And yet the physical security officer says, no, I don't want to have anybody see anything ever. And that's the area that we get into. And quite frankly, in between that domain, you now find cybersecurity because you've got people hacking in, you've got insider threats. So, oops, went the wrong way, sorry about that. Now, however, in the government, security is the straitjacket. It's the guardrails. It inhibits the ability to expand technology as fast as you would like to. And so because it rules that physical domain, that's where you run into conflicts. It also is grounded into the facility that you're in. And one of the things we're going to talk about is whether you're facility-based or network-based. And the issue with security is, particularly with the bracking that goes on and the changes that are constantly happening and the advancement of information technology, the real issue is one of being able to adapt and maintain that security environment instead of building a SCIF in one building and then having to build another one later on, and it becomes a question of affordability as well. Now, information technology has also grown at its own peril because it is, in fact, something now where computer systems, SCADA systems in industrial control, every aspect of our lives are really controlled by the computer and now as much by the internet. And because of that, we are now totally dependent. It's gone so far, gone so fast, gone so high that America enjoys a standard of living because of that technological advancement. But it's at our peril because we go so high, we can also are prone to failure. We're the guys standing out there that are the target. And so our adversaries know this. Small little example. It takes energy to run a computer. But now computers control our sources of energy. And if any of you are familiar with electromagnetic pulse, that's one of the threat vectors that rogue states like Iran and North Korea, aided by Russia and China, have been advancing. An EMP attack would take out our grid, could take it out for up to two years. That is a threat vector we have to be addressing. And that is exactly what particularly Iran and North Korea are moving toward. We have to protect ourselves. So the dependence on the intelligence and the fact that that intelligence can be used against us is a differentiator and something we have to deal with, and we have to be aware of it. And the cybersecurity world, as I said, kind of fits somewhere in between, and it's looking and seeking its own identity in terms of what is its domain, and how does it relate to physical security, how does it relate to information technology in general, and the advancement of technology. So, security. This is a phrase I've used many times. The real common denominator of the risks and the problems we have is always people and how to deal with the human interface. That's why we're going to talk a little bit about today about not just the endpoint, but the user interface itself. And so POGO has been one I've quoted for a long time. You guys remember Little Abner? Remember seeing this? Have you seen this quote before? Yeah. Well, it's true. Now, whoops. Okay, because people are at the heart of the problem, that becomes one of the most vulnerable points, particularly if you are like in a SCIF and the user interface is not well defined. So we need to take a look at that in more depth. And physical security, because it has been ignored and not integrated in with the other security elements, is one that needs to be addressed. And so the fact that there is no policy that gives any direction in this area, we're kind of flying blind. And we need to look at this closer. So, looking at the problem, kind of go through a few things. Some of this, as I put this together, as I said, this is a trip down memory lane, so I put this together, I ended up with a boatload of slides. So I'm going to go through some of the things fairly quickly and just comment on, from my historical perspective, on what I saw and what evolved. And then hopefully we can get through this quickly. But there are conflicting forces we have to deal with. I also wanted to address kind of the centers of influence as to, from a historical perspective, where and how things evolved. And then to narrow that focus as we go through this, to look at it from a physical security infrastructure perspective from the desktop. Now, physical security, we don't get into mobility as kind of an extension of that. Smartphones and getting into wireless environments is, we address it in some areas, but for the topics of this discussion, we're not going to be talking too much about that. But we are going to talk about the user interface, that human element, because that's the biggest unknown. That's the most uncontrollable security factor we have, both people attacking us and defending ourselves. And then, as I mentioned earlier, I mentioned this Macumber Cube. And when I had developed this safe of mine, which was basically an armored computer cabinet, about 1986, I came up with the idea up at Los Alamos Labs. It took me 5 years to get GSA to just look at it. But they didn't know how to evaluate it, because it was part physical security and part IT security. And of course, IT was still fairly immature at that point. So I ran across this captain in the Pentagon. In fact, our first customer was an organization in the Pentagon, and it was Captain John Macumber. And we got talking, and he said, well, you know, I developed a thing called the Macumber Cube. And if you look it up on the internet, you'll see now there's like 100 pictures of the Macumber Cube. But it basically sets up a three-dimensional model of how to evaluate IT security risk. And I took it and embraced it to kind of merge the physical security side into that. So we'll be exploring that, and then we'll come up with some recommended and solutions. Now, we have conflicting forces here. The forces we have, you have IT versus security. You have government versus industry. You have policy versus practice. These are things that we unfortunately have to live with. On the IT side, you have hardware solutions, software solutions, firmware solutions, software-defined networks. You have VDI, the virtual desktop environment, not competing, but trying to advance the state of the art in terms of the hardware solutions that have been prevalent. You have then the cloud versus the normal database environment. You've got all kinds of things, wired and wireless. You're looking at thick, thin, and zero clients. And these are all aspects of every application is treated a little bit differently. So how you secure it and how you manage it is all dependent on these different kinds of parameters. And what they do in a test lab versus what ends up being in the field can also be a challenge. On the security side, you got cyber versus physical security. How do you fit that together? One area we're going to be talking more about is the facility-centric security versus network-centric. And that's one area that we work hard in. The other side of it is, when you look at the user interface, is what is the balance between security and convenience? Because from a convenience point of view, it's easy to get in, it's easy to make things happen, it can make you lazy, you aren't compliant. But on the other hand, if it's too secure, you're not going to use it. Cybernet in the general's office, if it's not easy for him to get to, he has his aide going down the hall if he's at home or having to go into the office to do an email. So this relationship between security and convenience is important. And you also have what you do tactically out in the battle space versus what you do in garrison is also a different aspect of security. And then you have to look at the threats, the insider threat versus an outsider threat. And that's changed over time considerably. Now, as I was putting this together, I sat back and I was thinking about it last night, as a matter of fact, and trying to relate to what's the real problem here. Well, we don't want conflicts. What I would like to see, and what is kind of the reason for I'm being pleased, and I thank you all for being here to be able to hear my story, is that the real issue is we've got to turn those verses into ands. We have to change it from a conflict to a synergy so that it is information technology and security. It's the government and industry working together. That we can't be confrontational or be protecting our own little, that famous word, silos or stovepipes, whatever you choose. And so we have to look at how do you take practice and get it into policy. We're talking specifically about the endpoint right now, and the biggest problem I've got is there's no one on first. There's no one to go to. There's no one responsible for what happens inside a SCIF. Policy dictates how the SCIF is built. They work on equipment. They work on other issues. But that's one area that's a loophole that needs to be addressed. When you look at hardware, software, firmware kinds of solutions, they can work in concert together. We need to be looking at this as a collaborative, kind of a teaming effort that isn't dividing, but is in fact a synergistic building of a relationship, because we all have the same problem. We're trying to protect our stuff. We're trying to protect our nation. So this is real important. And when you have this synergy of wanting to bring it together, one of the guys I've always loved was Yogi Berra. It's amazing how prophetic he was, just being a catcher for the New York Yankees. He had come up with this quote: when you come to a fork in the road, take it. That's what I've been doing for 30 years. And I'm still standing, so I guess it's not too bad. But the point being that when you look at physical and IT security, you got to bring them together. You got to do them both. And that's what we're looking at here. Now, wanted to go into a little bit of the history. Now, I'm going to gloss over a bunch of this because I ended up kind of getting drunk on my own past a little bit and saying, whoa, this is kind of cool, and whoa, this happened. Oh yeah, I forgot about this, and I end up with a boatload of slides. So I'm going to slip through a bunch of these. I got a bunch of pictures and quite a bit of an age difference between people here. So some of you may not have known what went on in the Bay Area in the 70s or in the 60s, and what has happened in the 70s and 80s since. So I just wanted to trip ourselves through the history a little bit, but it also shows the variability of what went on in the IT world and what went on in the security world that was trying to support it. Because security basically had a tiger by the tail, and for the most part, didn't quite know what to do with it, except keep it in a box. So we'll look at information, we'll look at the security, look at the user interface, and I'm also going to emphasize a couple of just technological disruptions that really were game changers in how we affected this. Now, centers of influence. Obviously, Silicon Valley was the key progenitor of this. And one of the things that kind of surprised me as I went through it, a couple things I knew about because they were a customer of mine, was Xerox, the Palo Alto Research Center. And there is so much that got invented there. But the problem that we face, and this is something I've been facing all along, is that what engineers and technologists can do in the lab has to be translated into products, into a user interface, into some useful device or application that actually allows you to get work done, to accelerate what you do. Now, of course, you have Seattle with Microsoft and with Amazon up there. The other big contributor to particularly the move from analog to digital communications was Qualcomm down in San Diego. And then you look at the Northeast, and that's where a lot of like the semiconductor was invented at Bell Labs. And you had what they call the 128 corridor in Boston, which was where Digital Equipment was founded and Data General, and that was driven a lot by technology from MIT, as the Bay Area was driven by technology from Stanford and Berkeley. By the way, Sun Microsystems, Sun is an acronym that stands for Stanford Unix Network. So it was all evolving out of a lot of the academic work that had been done. Now in the government, a couple things that were important here. Obviously DoD with DARPA and with DISA had been promoting technology as it went forward, but it was focused quite a bit on the military side. And NSA, of course, even in the very beginning, the whole invention of the computer, going back to Alan Turing and before, was basically defined by crypto-analytical work and code breaking. First it was World War II, and then it was the Russians. And so that was the driving force that pushed people like NCR and IBM to get more into the computing world, UNIVAC as well. The last one is the one in the 60s that really propelled the microcomputer development, and that was getting the man to the moon, NASA. It was, you talk about synergy and teamwork of getting something accomplished. That was, I think, one of government's finest hours. In fact, not only that, in my view, getting Apollo 13 home was even better, because that showed the ingenuity of being able to adapt, not only with technical excellence to get the job done, but to make it work. So I'm not going to spend a lot of time here on, on the technology stuff. Basically, 50s and 60s, everything was big, huge, and I'll show you some pictures of that as we go along. And so everything, but it was always in one room. It was a fishbowl mentality, as they called it. So security was pretty simple, because there was no network. There wasn't anything that went out of the room. And so that kind of set the stage for how physical security evolved. But the real issue then came when it started to, oh, they didn't get one. When you start looking at how a mainframe computer was, it then started to spread out as technology evolved to mini computers, digital equipment being the first. So now instead of having a room full of equipment, they could do the same thing on a wall full of equipment. And it started to migrate out. And the real important thing here is you need to follow the data, databases, because in trying to secure these things, you now went from one big central room to several, and then as you got into microcomputers, it then just kept going, and then the internet comes and it just exploded to millions and billions of contact points that we have to deal with. So how you secure that, both physically and even in the cyber world, is a huge and ever-growing challenge. Now, On the physical security side, it was all in one room. They added Tempest. You're all familiar with Tempest? And that was because they found that these computers actually emanated and people could pick up the signals. So that gets added in. And then security containers, actually it was Eisenhower who first directed us to secure stuff because that became important. Now the one thing I want to talk about are these technological disruptions. The first, of course, was the invention of the semiconductor that went into the transistors. That was done at Bell Labs, and that drove the whole development of being able to do that. As I said, sending a man to the moon. And then there was this thing called Moore's Law, which was a guy named Gordon Moore, who was one of the two founders of Intel. Robert Noyce was the other one. And he had projected that every 2 years they should be able to double the processor speeds and the performance then of computers. And that kind of set the stage for this explosive growth of computers. In the physical security area, there was one thing that happened. People don't think about this much. It was Xerox again. They invented xerography. Because before, everything was typed. Any classified document was on a typewriter and had carbons. You only had 3 or 4 copies. You could keep track of that a whole lot easier. Now you get a copier in there and you can have hundreds of copies. Getting control of that was a major challenge. The user interface, beginning, of course, it was punched cards. 029 key punch. I actually programmed on it in the late 60s and early 70s. Wasn't fun because you couldn't make a mistake. Just like with internet, you can't miss a period or miss a character in an email address. It was the same with a punch card, except your whole program wouldn't run. But you also had the starting of the user interface because you had keyboards, you had Selectric typewriters, you had the beginning from actually IBM, who had built very proprietary computers. They started looking at the user interface with a CRT display. So now that coupled with Western Union coming out with a teletype, and that was the first printer terminal that was ever out there. Here are some pictures. We'll just step through these real quick. There's what a 360 looked like. And you've got the paper tape readers here, or the punch card readers here, reel-to-reel tape, disk drives, Selectric printer, and it's all a batched processed environment. You then go the disk drives. Before they were fixed removable, and that's how I got in this business, because it was removable disk drives that they would put in safes at night to secure them, and then put them back on the drives during the day. Well, when they went to Winchester hard drives without the removability, how do you move this 45-pound disk drive? And by then it was, these were 14 inches in diameter. The first Winchester drive was an 8-inch diameter drive, but it was like this big, weighed 45 pounds, and had a whopping 30 megabytes of data on it. So when you look at where we've come, it's been a long way, baby, I'll tell you. And it's been unbelievable, the technology that we've created. This is what a DEC computer looks like. And again, it's against the wall, and you have the teletype over here as an I/O device, and then they came up with their own CRT display terminal as well. This was the first teletype, and that was actually a DEC PDP-1E, their first early units. This was in the mini computer world. But also on this, they used paper tape as an I/O device. And that was what they had used a lot, even in encryption stuff in the early years with the military. It was a code set called Baudot, which was a 5-bit code. Then it went to 8-bit with ASCII coming online. So now we have IBM then starting out with their CRT displays. And now we get into the next set. And that goes through, first of all, Apple coming out in the mid-70s. In fact, the only time I got to see Steve Jobs, my career was at the Moscone Center when, 77 I think it was, when he introduced the Apple II. And I was at it was the West Coast Computer Conference or something, and I was out there at the time. But that was followed then by other microcomputers. And the one thing I wanted to mention to you is when you talk about Silicon Valley, you had a lot of pioneers. And you have two types of businesses. You have pioneers and you have settlers. Okay? Apple was a pioneer. They were a visionary. Now what they did is they went to Palo Alto Research Park in Xerox and were able to look at the Windows technology that they developed and other things, and then they brought that forward. But it was the pioneering of coming up with that user interface that was critical. Settlers are people like IBM, because they wait for the technologies to see if they're going to survive, and if they do. In fact, when IBM came out with their PC, I know this because a good colleague of mine was their power supply engineer. They had 4 different models of PCs because they didn't know which one was going to take off. So they had the money, they had the market, they had the proprietary, they owned the computer business. We'll do all 4. Now, we then saw the first email services starting to come out. They were based off of mainframes. And then you also saw, from a mini computer point of view, the starting of the distributed computer and the desktop workstation. And of course, NSA was strong on encryption, so now you were doing point-to-point encryption so that you could go from computer enclave to others. And you also then had the Rainbow series, the Infinite Orange Book that came out of NSA that was the Trusted Systems Evaluation criteria. How I ever got the name Trusted Systems, I don't know, when I trademarked it in 1988, but I was blessed to be able to get it. But the disruptions then were a couple things. Xerox, they invented Ethernet. I didn't know that before. And Qualcomm, of course, pioneered digital communications, which allowed for a tremendous increase in speeds, because you were going with acoustic couplers, analog, sound over copper. Now you're going digital signaling, so the bandwidth and speeds just were astronomical. So as the computing processor speeds were going up, you had the speeds of communication going up, so the I/O could increase. It was all kind of feeding together. You also had optical fibers taking over for copper. And the other thing that was a big thing, I'll show you a picture of it in a minute, was a product from Xerox called the Alto, as in Palo Alto. And that was the first Windows icons mouse-based device ever put out on the market. They also had a LAN setup, they had applications. It was a complete computer system all by itself. The problem is Xerox always had a problem in the computer business of knowing what to do with it. And they had one called Xerox Data Systems, XDS. That was the precursor of both Apollo and Sun. They had great stuff, but it just didn't know what to do with it. So that coupled with Xerox coming out with laser printers, again, the speeds accelerate in all these different technologies. And then you had in the 80s the evolution of what was originally called Arpanet, which was a DARPA-initiated scientific and research network set up between universities and the national labs to do research. Physical security, basically, it pretty much stayed the same. As I mentioned before, you went to removable, to the hard drive environment became a problem. LANs and everything were getting spread out. Now you're getting the tentacles being almost uncontrollable. So they pretty much stayed in the same environment. It was going to be fixed, in-place security for that environment. Now, let's see here. The user interface, very quickly, went from IBM CRT to a standard video display terminal, keyboard monitor. When the Xerox Alto came out, it added the mouse and the icon. So now you had what we now call the KVM, the keyboard video mouse desktop, which we have in some form or another to this day. That hasn't changed. So that pretty much plateaued. Physical security had plateaued, the user interface had plateaued. It was just the IT technology that was going through the roof. Then other applications like video teleconferencing started to come online. So here's what they looked like. There's Apple and IBM, and this is what the Alto looked like. Didn't sell very many, but it gave you Steve Jobs. Now, I only mention Steve Jobs here, and I put his picture in because of anybody that I ever was aware of in the Bay Area. The real visionary of the user interface was that man. Because he took what Xerox had developed and made it usable. Added graphics, added calligraphy text, added all kinds of things to make it appealing, but to also make it work. Have any of you heard the story, the bike story of Steve Jobs? Where when he was selling the PC when it started, he was asked about why the PC? And he said, well, there was a Scientific American article, 1973, I think, that rated the efficiency of locomotion of higher order animals and man and jets and machines. And it turned out that like the salmon was one of the most efficient, so was the condor, as he said. And man was about 1/3 down the chart in terms of efficiency of motion. And that was per weight, per calorie, per kilometer, I guess. But Scientific American was doing an article on bicycles, and they put man on a bicycle, and it went off the charts. They were 5 times more efficient at energy consumption than they were walking. And so Steve Jobs made this analogy that man as a high order is a tool maker because we want to amplify our productivity. And so he called it the bicycle of the mind. That was the personal computer. That was how he originally sold it. And so it's this acceleration effect that really had taken off and defined the user interface and how important that was. Then you had people like Sun, where they had both servers and workstations, and their advertising campaign was, the network is the computer, so that now the network is distributed truly. So here we have just a quick review of things going from vacuum tubes to microprocessors, 1904 to 71, mainframe, mini, micro, personal PC, and then the commodity PC, which was the IBM clone thing. And that was what took the personal computer into the business world and made it a commodity product. And that's how that evolved. And then, of course, software ended up going from batch processing all the way to the others. There was a tipping point around 1990, and that was a significant time for us. A lot of things changed. First of all, the infrastructure, which had been processing-based beforehand, got changed to communications-based because of the distributed network. So the focus and attention on infrastructure shifted at that time as well. But also a couple other things happened. The wall came down. Our threat vectors changed. It was not a bipolar threat anymore. It was rogue states. Terrorism was coming online. We were looking at other things that were going on here. So that is what really allowed us to advance through other things. And since then, of course, the internet was the third thing that happened in the early 90s that just exploded the whole aspect of connectivity. And that coupled with the laptops and notebooks and smartphones. And now we're into the JIE environment where we now look at multi-domain, we now look at all kinds of these other technologies. But as it relates to physical security, the one thing about physical security that we try to do is to make it impervious to the technology or hardware that you secure. The safes that we installed in 1993 and 94 are still being used today because they just upgraded the hardware, upgraded the technology, upgraded the user base. And so that's how that evolved. And from that point of view, it was, and I guess you can call it a technological disruption, we had created this thing called an Ips Security Container, which basically became an armored computer cabinet so that you could detach the physical security from the room and tie it to the network. And that was a big change. The whole concept of PDS, you went into optical fiber and went into other things, but basically that didn't change much. Here's what it looks like. Now, the user interface stayed pretty much plateaued. As I said, it was a KVM. Now, what's been happening is there's been a consolidation of networks. They want to be able to have red switch, voice over IP. You want to be able to have VTC terminals. You want to have NIPR, SIPR, JWICs if you have the room for it. And that's what's really evolved. And so that is where we've been going into this multifunctional, multi-domain environment. And in fact, created where we put a safe in furniture. This one happens to be in General Abrams' home at Forscom, Fort Bragg. But you can now have a, I know I'm trying to make gray safes look sexy, right? Actually, the whole initial intent was for the general to allow, or his wife to allow him to have SIPRnet in his home instead of in the garage or the basement or somewhere else. But actually, the important thing about this gets into the user interface, and that has to do with, one, the concealing of the fact that a classified presence is there. You're in a conference room where you're doing part SIPR, part NIPR. You can just have a cabinet over in the corner. Nobody knows it's classified until you actually bring it up live. When you have the need for consolidating these functions together, it makes the management and control of it that much simpler. Here's what happened with Moore's Law. It actually took place from up to 2011. It's kind of flattened out since then, but it really grew at that pace. And the problem was, of course, the future ain't what it used to be. I had to throw Yogi in there just for a quick little adder there. That the whole concept of physical security, unfortunately, did not change with technology. It constrained it. And so now, since there was no Moore's Law that applied to it, you have to look at how do we adapt the principles that we know work in physical security to a networked environment, not a facility environment. And what has been, because most of the effort and money, time has gone into it, the cybersecurity approach has been the one that has been mostly adaptive to going after the insider threat. But the problem is, it's reactive. It's not proactive. It reacts after the threat has occurred. They do behavioral, they'll do traffic analysis, they'll do persistent threat analysis, but it's always kind of after the fact. You're playing catch-up ball, you're on defense. And it's hard. Now, you have the whole offensive environment with cyber, which is a whole different realm, but when we're protecting our stuff, the whole concept of cyber is a real challenge. So you need to augment it with other things. And, of course, with physical security, deja vu all over again, you're into that environment, but the user interface that hadn't changed, of course, it went into mobile, and as I said, we consolidated a lot of these functions. So I won't delve too much into that. But the fact that I wanted to talk about here is that the dependency that we have on computers and the involvement of SCADA systems in process control and in utilities and water treatment plants and everything else has increased, coupled with the internet, has increased our dependency at a point where we have to look at all the threat vectors. And the endpoint is one of them. And even though the cyber looks at it from an inside-out perspective, the physical security side that we work on works from the outside in because it's physical. And we try to make it proactive. And unfortunately, even though the tightening of vetting and the other things that have happened, from a physical security point of view, we still have these major breaches. And that's what we have to stop the bleeding on. And we think that physical security can help this. Now, here's the Macumber Cube. I'm not going to go into a lot of the detail on this because we're running a little bit out of time here. But basically what John Macumber did is he looked at the information states, where the data resides. Now, this was done in 1991. So what I wanted to do was to use this model to kind of interlace physical security into the IT security risk management environment. The processing, storage, and transmission are the three states. That's where the data resides at any point in time, and how do you protect it, and how do the other aspects of the human activity, technology, and the different forms of what you want to protect in terms of the states of the data, how that actually gets physically protected. I would add another link into that, and that would be from the transmission point, you got to get to the endpoint. You got to look at the user interface more. And that's one of the elements. On the second side, where you're talking about critical information characteristics, that's really the what. Now, you may have seen these three words in a lot of different security briefings and things of sort: the confidentiality, the integrity, and the availability. And from that standpoint, basically the confidentiality is making sure that only authorized people have access to it. The integrity is making sure that the data is accurate. Big problem is the denial of service threats, okay? And the problem is a lot of our threats are not, they either come in two forms. They either are a denial of service threat, or they want to break things, or they want to steal it. And so when you look at how you relate integrity, confidentiality, and then availability, is then making sure that the data is there for people who need it. Now, the real important thing about that is this. It has to do with time. Because we live in a real-time world now, and the availability of information is critical to making sure where you have a drone up there and you've got a guy with a laptop out in a foxhole, you've got to get that data to him to be able to make real-time decisions. And that whole time factor is something that's very critical here, because it's time to respond, it's time to make decisions, time to get data, and also the time to make it available so that you can react. The other aspect is one that I would also expand on, and this has to do with the human interface. Whoops, wait a minute. Sorry about that. And that has to do with human factors. He has an area here where we talk about the education, the training, and awareness. That's assuming you already have a vetted, qualified user. We can't assume that these days. A lot of times, either based upon greed or ideology or something else, you have people don't thinking they need to protect it. They're not mission-driven, as they should be. And that's something I think that's part of the culture. I think when you look at Instagram and Facebook and everything, kids and particularly young folks want to share everything with everybody. It's that getting it out there all the time. Their sense of security and propriety and proprietariness is, I think, impacted here. So it's a cultural thing we have to deal with. So there is a human interface, the man-machine interface element to this part of it that is important. The second part is the policy and practice. Now, I wanted to go down, I defined all these states and went through them, and I just described it to you, that when you look at processing, have you all heard of Zipper Tuesdays, where you have to reboot your laptop every week in order to get the latest Microsoft updates and all that? That's a real constraint on performance, and it really works against getting stuff done. So that people either don't do it or that it just holds things up. But you also have from a storage point of view, obviously that these things haven't changed. And the transmission, again, it stops at the wall. It needs to go to the desktop. It needs to involve the user. So we would expand a couple of links onto this Rubik Cube kind of box. And then we look at the confidentiality. We've already discussed this, so I will step through this. The integrity is the accuracy, and the availability is that authorized people have it when they need it. Then we get to the education training. And the human factors, I think, have to be put in there. There's got to be better vetting, there's got to be consistent supervision, but you also do need to track performance and behavior and keep up on this from an insider out as well as an outsider in perspective. In fact, there's one thing I wanted to show you. This is a good thing from policy and practice. Again, a lot of times policy gets created up here in the ivory tower, the 30,000 foot level, but at the practical level, as it says here, oops, what did I get that for? The one thing I didn't do before I started. In theory, there is no difference between theory and practice. In practice, there is. And the problem we have, and I wanted to go to this slide here. Oops, wait a minute. Let's do this first. In the policy area, when it comes to the endpoint, there are really only two things that has been done. There's a DISA-STIG that's out there that mandates that because the policies are disjointed, you have SCIF policy, you have PDS policy, you have IPS container policy, and then you have like what our SAFE does. But the problem is they're disjointed. There's no seamlessness to them. The endpoint doesn't have anything. And because of that, that's why this collaboration with cyber and physical is becoming more and more important. Now, there is a DISA-STIG that mandates, number one, that you have this data stored in a CAA. They also now say that an IPS container is equivalent to a CAA. But the second check is the most important one, that only network administrative staff shall have access to network connections, switches, routers, encryption devices, and so forth. And that's being used today. However, that's a guideline. That's not a policy. And that is something that that is really driving this right now, but it's really just a very small little shot in the dark to try to get some control over the spreading of all the switches and routers that have been out there for so long and the lack of control. The second thing is, and this just came out, I think in 2015, and that is in the PDS spec, the protective distribution spec, when they did talk about connectivity at the endpoint, so they say you have a lockbox at the end, they did say terminal equipment must be safeguarded to prevent tampering. What that means, who knows? It was a very vague statement, so it kind of throws it out there and said, yeah, you need to be tamper-proofing. There are people that we're working with. In fact, we've just developed a version of our safe that is made out of sheet metal instead of hard plate. And that's just to be used to protect hardware, PCs, servers, in a classified, in a SCIF or in a CAA, just for tamper-proofing. So there is movement in that area, but it's very, very slow. And I think that let's see what we're looking at here. When you look at the security measures that you can apply, you basically have three. Some of the things I had thought about here in conclusion was to look at space, where you have a SCIF, but once you're in the SCIF, network equipment is exposed and accessible. And that's because the whole definition of a SCIF has changed. It used to be the center of computing activity, a meeting room, a conference room. Still is. But it also, its main task now is that it is a network portal. So now you have a problem with what do you do with that equipment that's in there? It's not secured. That's the real risk factor there. IPS containers we've already described, and storage containers are offline storage. That takes the equipment away from the network, and that makes it even more unstable and not a very good thing. Here's what the SCIFs look like. They are expensive. They are permanent. They don't have a user interface. And they are basically a reactive intrusion detection. So you need to have something that's more proactive, that actually looks at responding to a threat, not just with people. Now, SCIF, I kind of use the Maginot Line, if you remember back from World War I and II in France. They put this big, beautiful fortress underground, and the Germans just took tanks and went through Belgium, right? Whoop, did an end run, and that was the end of it. Now, described what the IPS container does. We've been through that. We've even now adapting. Part of the issue here is we want to have legacy backward compatibility. So we've taken an actual PDS Dropbox and built it into the back of a safe. So you can put in encryption in there, and you can use it as a patch panel, so you can plug into it just like you would into a wall. So some of it is this legacy type of thing. Here, of course, is where technology and all the different protective measures you can put in place, but you notice half of that equation is the people. And what really merges the two and makes the two work is effective policy. So they have to all work together. And I think that when we look at how SCIFs evolve going forward, we're looking at, they're more for the larger computer center, cloud environment, data center environment roles, and that when you look at the small seat count stuff, that's where the safes can come into play. There is a scaling there that you have to deal with. The other recommendation is that DoD has said, and I've heard from a number of people, that they really want to get out of the PDS business because it ties them like an albatross around their neck to the facility. There's too much bracking, there's too many things going on, that they need to find an alternate way to doing that, and encryption makes that work. And what I've always used, does your security officer sleep well at night? Because a lot of security is perception. It's what works and doesn't. And then the bottom line, we're ending here, is that they are portals, they do not protect the equipment, and the IPS containers do in certain environments. Again, it's a layered type of defense. And the main reason is because it's not tied to the network. I mean, it's not tied to the building, it's tied to the network. So you can move it, it's transportable, it doesn't get obsolete. But also, you want to have the ability, and we have the ability of remotely monitoring the door of the safe itself, so that if someone tries to open it, we can actually shut that equipment down remotely through what they call S&MP traps, through basically the same way your intrusion detection system works, just adds to it. And we also have a way of controlling the user interface so the user never gets into the safe itself. Now, the ending is here. We need to work with cybersecurity because they work from the inside out, we work from the outside in. They're reactive, the physical security side is proactive. They're software-based, we're hardware-based. We can work together in that area. And we complement each other. So all we need is a policy. And by the way, the other problem is finding an agency to step up to the plate and take charge. So that's it. I appreciate your time and attention. And do you have any questions? Which means either I explained things extremely well or I didn't. Or I'm competing with happy hour. Yeah, I knew I was going to run up to that. I can't, I'll love you, man, but you can't have my bud, right? So, Anyway, but I thank you so much for your time and attention. Our company's down at booth 111. You want to stop down and see what we're doing. But I want to thank you so much. Thank you.
Thank you, Bob, for the history lesson. Get relate to some of those topics. I have the scanner, those that want or need credit. Before you leave.
Hi. Hey, thank you. Bob Bauman's my name. What is your name?
Sid.
Hi, Sid. Nice to meet you.
Nice to meet you.
Hi, thank you so much. Hi, Bob Bauman. What's your name?
I related Cynthia Jones. I related to a lot of that.
Did you? I noticed. I could see the smile. There you go. That's a real problem. How do you do? Bob Bauman, nice to meet you.
That was interesting.
Bobby.
Finally one that
Thank
hit
you.
both the realms that I'm used to.
Oh, it is,
Considering
huh?
My first 8 years in the Air Force was security police.
Oh,
And
perfect,
then my last
right.
12 years was IT management. So
So you guys were the boots on the ground, weren't you?
yeah, that's why I was looking. I said, yeah, actually the problem is that security police we're non-technical. We're just used to pretty much keeping everybody out, checking badges, and then on the IT side is pretty much making sure everything else is operational, just
Right.
trying to mix them together.
Mm-hmm.
Thanks. Enjoyed the history lesson.
You bet, well, thank you.
Uh,
Well, part of it is understanding the context of how we got to where
it's nice.
we are.